Let's get right into it. Your phone is lying to you. I'm the Viral Clarity Architect, and welcome to our explainer on cellular connectivity. Today, we're moving you from helpless frustration to forensic competence. We're going to completely destroy the myth of signal bars and rebuild your mental model of how your network actually works with surgical precision. Because frankly, clarity is the ultimate retention hack. Let's dive in. Seriously, have you ever stared at your phone, seen 5 glowing bars of 5G, and yet you completely missed a critical call? You check your log and it just says missed, with 0 rings. It's absolutely maddening. But here's the core contradiction that proves your screen is straight up lying to you. If you were to dial emergency SOS right in that exact moment, the call would go through perfectly. Why? Because emergency SOS uses a completely separate, unauthenticated bearer on the network. It bypasses the standard permissions your normal, everyday phone calls actually require. So what do those bars actually mean? Well, they measure something called RSRP, or Reference Signal Received Power. Think of RSRP like a giant, dumb flashlight beam reaching from the cell tower right to your phone. It tells you how bright the light is, but you know what? It tells you absolutely nothing about whether you have permission to actually communicate over that light beam. Your signal strength is literally just a physics measurement. It is not an authentication status. To actually make a voice call on a modern 4G or 5G network, you need IMS, the IP Multimedia Subsystem. Think of IMS as your VIP backstage pass. You can see the stage just fine. That's your cell tower, your 5 bars of RSRP. But without this valid VIP pass, which requires a successful SIP registration with the network, the bouncers are going to block your voice call from ever connecting, no matter how angrily you tap your screen. Your data might work, sure, but your calls, they fail silently. And this brings us to how the plumbing actually works. We've got to stop looking at the bars and start looking at the triple-layer stack. At the very foundation, we have Android's Carrier Services app, which manages the communication logic. That app controls the IMS daemon, which handles that VoIP SIP registration we just talked about. And finally, that registration routes through a dedicated IMS APN, or access point name. If literally any one of these 3 layers breaks, your calls just drop into a black hole. Section 1, the 3G sunset, the disappearing safety net. So why are you experiencing these ghost missed calls now more than ever? It's because the old 3G circuit-switched safety net that used to catch your failed VoLTE calls is completely gone. Looking at this timeline, you can see the dominoes falling globally. In the USA, major networks killed 3G back in 2022. Australia shut down in 2024. The UK is finishing their sunsets right now across 2024 and 2025. With these legacy networks gone, IMS and VoLTE support is no longer just a nice-to-have feature. It is a strict, non-negotiable requirement. Without a functioning IMS stack, your modern smartphone literally has no physical way to route a traditional voice call. Which brings us to a very specific and honestly very problematic number: 48. This is the number of hours in Verizon's default Android carrier configuration for IMS registration renewal. Now, the 3GPP standards mandate that IMS registration should renew every 12 hours. But this 48-hour timeout completely violates that mandate. So what happens? After a couple of days of uptime, your device's registration just expires behind the scenes with 0 visible notification to you, leading to this massive, silent call delay bug. Let's deconstruct the specific hidden killers causing these behind-the-scenes failures. First up, that 48-hour timeout we just mentioned means the SIP register handshake fails to renew, which returns a hidden 403 forbidden error. Second, Android's very own adaptive battery feature can silently kill the IMS daemon and carrier services in the background just to save a little power, which instantly drops your registration. And third, a missing IMS APN due to profile corruption means your data works fine, but your voice calls fail. And the crazy part? All of this happens while your phone proudly displays 5 full bars of signal. Section 2, the live debug, forcing IMS registration. We know the bars are lying, and we know the stack is breaking, so it's time for a live debug. To do this, we have to bypass the standard user interface. Open up your Android dialer and punch in this exact code: *#*4636 #*#*. This is a system-level command that throws you right into the raw Android radio info testing menu. It's the diagnostic dashboard your carrier uses, stripping away all the UI marketing fluff. Here is the exact 45-second sequence to manually force a fresh IMS registration. First, in that 4636 menu, tap Phone Information. Second, look closely for your IMS registration status. If it says not registered, bam, you found your ghost signal. Third, scroll down, Tap Turn Off IMS. Wait 3 seconds, and tap Turn On IMS. Finally, tap Run Ping Test. What you're desperately looking for here is that status to flip to a beautiful green registered. That proves your VIP pass is active once again. But look, we don't just want to fix it once. We want to prevent Android from breaking it again, right? Remember how adaptive battery kills the IMS daemon? We need to unblock carrier services. So go into your normal settings, navigate to apps, and make sure you select Show System Apps. Find both IMS service and carrier services. You absolutely must set their battery optimization to unrestricted and enable background data. This stops Android's job scheduler from suffocating your connection, guaranteeing those vital SIP Keep Alive packets, which is essentially your phone continuously waving to the tower, can actually reach their destination. And there's one final step to clear out any deep system caching. You need to reboot the phone, and once it boots up, toggle your Wi-Fi calling off and back on. This is a pretty clever trick. It forces the OS to trigger a fresh entitlements check with your carrier's server. It clears out any stale E911 addresses or expired cryptographic handshakes. Only after this entitlement check actually succeeds will your network features be genuinely, reliably active. Section 3. The Takeaway Toolkit, your IMS diagnostic flowchart. We've covered the underlying architecture and the forensic debug, so I want to leave you with a permanent reference tool. Let's lock in this new mental model. If your calls fail, but your internet data is working perfectly, then immediately check your IMS status via that *#*4636 #* dialer code. If that IMS status reads not registered, then go unblock carrier services from your battery savers, reboot, and toggle Wi-Fi calling to force an entitlements check. And finally, if your VoLTE or Wi-Fi calling toggle is entirely grayed out and you literally can't even click it, then it's a provisioning error, and you need to contact your carrier to refresh your IMEI and SIM on their end. You are troubleshooting the stack now, not the screen. When you understand the engineering behind the interface, you stop being a victim of bad software design. You now know exactly what happens behind the scenes of a 4G and 5G network. I highly encourage you to share this explainer with anyone in your life suffering from randomly dropped calls or missed emergency alerts. Stop trusting the bars. Start checking the stack. Clarity wins. But honestly, it makes you wonder, if your signal bars have been lying to you this whole time, what other icons on your screen are hiding a broken system?